Now let's take a look at rational equations. In the previous video, we looked at fractions in an equation and showed how we could use the least common denominator to clear the denominators in the equation and create a much simpler equation to work with in order to solve for our variable. Quick reminder in regards to expressions and equations. A rational expression is just a collection of terms. We do not have an equal sign, but an equation, there's an equal sign. And we will use different strategies for expressions than we would equations. We have more tools in order to simplify and solve equations in comparison to what we have for expressions. Expressions are pretty strict. We cannot multiply by whatever we want to or add or subtract whatever we want to, because we cannot change the overall nature of the problem. We can only change the look of it. So for a rational expression, we want a common denominator so that we can add those fractions together. But in a rational equation, we want a common denominator so that we can clear the denominators in the equation and be able to simplify it. So in order to use the LCD in the first problem differently than we would in the second problem, we use the LCD to find our special forms of 1 that we multiply by each of the terms so that we get those fractions to have common denominators. In the second problem, we use the LCD to multiply both sides of the equation and clear the denominators. I'll let you write those in your own words. Let's take a look at simplifying. Simplify the first problem, showing all your steps. So the first step is to determine what is that least common denominator. And we look at the first fraction. The denominator is x plus 3, so we'll write that down. We don't have to worry about factoring. There is nothing to factor out. These are as simple as they can get. So we take the whole denominator. We look at the second fraction. Is that denominator expressed in our LCD? We do not have x minus 3, so we're going to include it in our LCD. Now we can multiply both of these expressions, both of these fractions, by special forms of 1 so that we can get them to have common denominators. So the LCD here is x plus 3, x minus 3. I already have x plus 3 in this first term, so I need the x minus 3. But I don't get to just include it in the denominator. I need to multiply by a special... I need to multiply by that special form of 1. And similarly in the second fraction, my denominator is x minus 3, so I need the x plus 3, and I have to multiply by that special form of 1. Working on this part, now I have that common denominator, x plus 3, x minus 3. In the first fraction, we have 2 times x minus 3. In the second fraction, 5 times x plus 3. Again, with that same common denominator. And now, because we have common denominators, we get to write both of these numerators on the same fraction. So we'll put our common denominator there, and then we've got 2 times x minus 3 plus 5 times x plus 3. Multiply them out. We need to distribute these coefficients using that distributive property. 2x minus 6, 5x plus 15, all over x plus 3, x minus 3. And now we combine like terms, so I combine my x terms, and I combine my number terms on top. So 2x plus 5x will give me 7x. Negative 6 plus 15 will give me a plus 9. X plus 3, x minus 3 still on the bottom. And this could be my answer. Or if we want to multiply out the denominator, we could. And this is a difference of squares. We'd multiply it out and get x squared minus 9. Either of those are acceptable answers. But notice we have an expression as the end result, not an equation with a variable equals a number. Looking at the second problem, now we have an equation. How would we use the LCD for the equation? Let's copy back over that same LCD because we have the same fractions in this problem. X plus 3, x minus 3. And this time, we're going to multiply both sides of the equation. And I'm going to be really careful about this so I make sure that I get both sides of the equation in here. I'll multiply the left side of the equation by that LCD, and I'll multiply the right side of the equation by that LCD. So I'm applying that least common denominator, multiplying both sides of the equation by that LCD. I'm allowed to do that because I'm multiplying by a non-zero number. At least I think I am. More on that a little bit later. We have to be really careful when we multiply by variables because we could introduce extraneous solutions. I know that's a big word. All this really means is that we end up with an answer for x that does not actually solve the original problem. When we multiply by variables or divide by variables, there's a possibility that we can add solutions or we can eliminate solutions that should have happened. So we want to be very mindful when we're working through these problems. And all it really means is we're going to go back and check our answers. So big picture, we learned before for rational expressions that when the denominator is 0, that is bad. So before I go any further on this equation, I'll make a little note. X cannot equal 3 or negative 3. And I'm getting that from this least common denominator. If I take x plus 3 and I set it equal to 0, I'll get x equals negative 3. And if I set x minus 3 equal to 0, and I add 3 to both sides, I get x equals positive 3. These values will make my denominator 0, and I do not want my denominators to be 0. Okay, more on extraneous solutions later. Now let's first distribute that least common denominator into these two terms. So x plus 3, x minus 3, times 2 over x plus 3 plus x plus 3, x minus 3, 5 over x minus 3 equals x plus 3, x minus 3. I could multiply that out, get x squared minus 9. I can't cancel anything on the right side, so we can go ahead and multiply that out. And now I can cancel denominators. X plus 3 will cancel in the first term. X minus 3 will cancel in the second term. And we're left with 2 times x minus 3 plus 5 times x plus 3 equals x squared minus 9. And since I'm running out of space in my page, I'm just going to pop up here and multiply out, do that distributive property here on the 2 and the 5 inside the parentheses. So 2x minus 6 plus 5x plus 15 equals x squared minus 9. Combine like terms, 7x plus 9 equals x squared minus 9. I notice that I have a quadratic equation, and quadratic equations we learned before. We need to move everything to one side of the equation so that we'll be able to factor and then solve for the variable. So I'm going to move everything to the right since I already have that x squared there. It's positive. It'll be a little more difficult if I try to move everything to the left. You should still get the same answer, but it introduces a negative sign in the front, and I don't want that. So let's subtract 7x and 9 from both sides. 7x minus 9. I don't have x terms on the right side, so all of this on the left becomes 0. X squared minus 7x. Negative 9 minus 9 is going to give me negative 18. And then I can factor. So using your factoring skills, factor the trinomial. Should end up with negative 9 and positive 2. And then if we set these factors equal to 0, x equals 9, x plus 2 equals 0, subtract 2, x equals negative 2. Now these I should check back into the original equation. It's always a good habit to check by plugging them back in. One thing I can do really quickly is to check against what x cannot be, because that's how the extraneous solutions get introduced. Up here, when we multiply by the least common denominator, there's a chance we could be multiplying by 0 if x equals 3 or negative 3. We have a problem. So we could introduce a solution of 3 or negative 3 for this particular problem that would then be extraneous, and we would have to toss it out. So we get two solutions, x equals 9, x equals negative 2. Again, always a good idea to go back and plug it in. How do we know when we can simplify and we can solve? We simplify expressions, and expressions have no equal sign, and we solve equations which have an equal sign. Let's do another example. I'm going to skip the section on simplifying because that's really what we did before. So let's skip those. I'm going over to solve the following equations. I'm going to do the ones on the left, and I'll let you work on the ones on the right on your own. You can always go to the OneNote and check your answers and make sure that they are good and show all our work. So in the first equation, we need a least common denominator. We'll take everything in the first denominator, x plus 1. We look at the second denominator, x minus 1. It is not present in my least common denominator, so I'm going to include it. And now because I have an equation, I can multiply both sides of the equation by that least common denominator. So multiplying both sides by the least common denominator, now we can cancel fractions, cancel common factors. X plus 1 in the first on the left side, x minus 1 on the right. 3 times x minus 1 equals 5 times x plus 1. And then we can multiply this out. So let's subtract 3x from both sides, and then subtract 5 so we can get that 2x isolated. And I'm going to come up here for a little more space. Negative 8 equals 2x. The operation being done on the x is multiply, so I need to do the opposite operation, divide. And x is negative 4. Draw a box around it, come back up here and check. In my least common denominator, x cannot be negative 1 for the first parentheses, and it can't be positive 1 for the second parentheses. Again, referring back to our equation, I cannot have zeros in denominators. Let's see what would happen if we checked. So if you go look on the OneNote, I am not going to keep the check there just for the sake of room. I may move it over to the side though, so you have a chance to look at it. So checking my work, plugging in negative 4, 3 over negative 4 plus 1. Does that equal 5 over negative 4 plus 1? I'm sorry, negative 4 minus 1. Heck. And then we simplify the left side. 3, negative 4 plus 1 is negative 3, question mark. On the right side, negative 4 minus 1 is negative 5. And hopefully you can see it. 3 divided by negative 3 is negative 1. 5 divided by negative 5 is negative 1. And it does indeed work out. We'd solve 12 the exact same way. Try it on your own. See if you can come up with the correct answer. And again, you can check your work in the OneNote. Let's get a little more complicated with number 13. So now we don't just have a fraction and a fraction. We've got another term here that we have to make sure we consider. We can't leave them out with whatever we do. So first step, find that LCD, x plus 7. I already have x plus 7 over here, so I do not need to copy it again. So I'm going to multiply both sides by x plus 7. Multiply that side of the equation, x plus 7. And then because I have two terms on the left, I'm going to distribute. Please don't forget to distribute. If you don't distribute, things go bad. And let's cancel some common factors so I can simplify my equation. And I get x plus 7 minus 4 on the left and 5 on the right. And then we can simplify on the left. 7 minus 4 is 3. X plus 3 equals 5. You probably see it right away. X equals 2. Quick check up here. LCD x cannot equal -7. We did not get -7. We can check with the 2 and make sure that it works. And in the last example we're going to need to factor. So for both 15 and 16, just notice we need to factor these denominators so we can find our LCD. Good news with this first fraction, 5 is a common denominator, so we can factor the 5 out. And then to form my least common denominator for this problem, I'll take everything in the first fraction, 5x plus 1. And then I look at this next fraction. Do I have x plus 1? Yes. I do not need to copy it again. And then I look at the last fraction, 5. I already have it, so I don't need to copy it again. And now we get to multiply both sides of the equation by our least common denominator. Left side, I'm going to replace the 5x plus 5 with my factored form. And then 5x plus 1 times the entire right side. 3 over x plus 1 minus 7/5. Be really careful here that you distribute to both terms on the right side of the equation. So here's what I mean by that. We can cancel common factors on the left, and we're left with 1. On the right, we need to multiply it out. X plus 1, and then minus 7/5, 5x plus 1. Remember, multiplication is commutative, so the fact that I'm moving the 5 times x plus 1 to the right side of 7/5, it isn't a big deal. It shouldn't be a big deal. First term on the right, I've got x plus 1s I can cancel. And then the second term, I've got 5s I can cancel. Now let's write an equation that's easier to solve. 1 equals 5 times 3 minus 7 times x plus 1. And we can simplify. 15 minus, I'm going to distribute the 7, 7x minus 7. I can combine my like terms on the right. 15 minus 7 is 8. I can subtract 8 from both sides. -7 equals -7x. I divide by 7, -7. And we end up with x equals 1. A quick check back up here with our least common denominator. X cannot be -1 because -1 plus 1 would give us 0. And it's not. X equals 1. Again, we could plug it in and check, make sure that it works all the way through. Try the other problems on the right on your own, see if you can do them. I'll post the answers so that you can check your work. Keep practicing. Rational equations can be cumbersome and long, but take your time with them, and if you need help, always reach out.